Now, titles like this, I ain't gonna lie, it caused my anxiety to kind of go crazy. You know what I mean? When you say things like over 750 trillion stars, not millions, not billions, trillion stars suddenly disappeared, I automatically start going, but why? That means something. Something's happening. It's trying to tell us something. We need to pay attention to this. We need to look into this. Like, I start literally over analyzing and looking into things and trying to figure out what's the why here. What's the reasoning? And it says, but now something has emerged. So listen, man, if that crash or alleged UFO crash in Las Vegas don't have y'all antennas up right now, I don't know what's gonna get you there. So we're gonna get into this video, man. They already got Neil deGrasse on the screen, so we're gonna check this out. If you're new, you know what to do. Hit that subscribe button, join the family, and hit that like button for more content. Let's check it out.
There's this period of time we identify as the Dark Ages, where, yeah, there was matter and energy, but nothing shining yet. And now, the James Webb Space Telescope is identifying objects in the Dark Ages.
When looking up at the night sky, you will see thousands and thousands of stars. To us, it seems like those stars are never ending. We know that those stars will always be there when we look up. But have you ever wondered what really happens to the stars in the universe? While using the James Webb Telescope, scientists have detected a mind-boggling 750 trillion stars gone missing. Where did these stars go? And how is it possible for them to seemingly disappear into the void of space? Join us in this video as we explore how over 750 trillion stars suddenly vanished in space and the effects this will have right here on Earth.
Them probably, whatever happened to them, it probably increased like the radiation levels, man, significantly, if I had to imagine.
Scientists have discovered that there is a yawning gap in space. They believe this yawning gap means that a good part of our universe's history went missing with the void.
Yep.
We, humans, are a species that have a deep connection with our past, as we believe that the past is what shapes the future. We like to look into the past and see how events of the time shaped the future we see today. Scientists often devote a considerable chunk of time to finding out about the history of our universe. Just like our history shaped our present reality, the events that led to the birth of our universe and the events that followed the cosmic dawn helped to shape the current stage of our universe's reality. Sometimes scientists come across astonishing discoveries outside the scope of the familiar, and the joy and wonder that come with such rare gifts are incredible. One such case happened a few decades ago. In 1981, astronomer Robert Kerzner, with some colleagues at the University of Michigan, attempted to calculate redshifts. Redshifts are a measure of how fast an object moves away from the Earth or a more significant number of galaxies. Our universe is constantly expanding. Due to this, the farther away a galaxy is, the faster it moves. Scientists use this redshift to measure distance, so Robert and his team attempted to use this method to create a 3D universe map. After finishing the map, they made a shocking discovery. About 700 million light-years away from the Earth was a blank void.
You know, I always wondered how they calculated that stuff, and now I know redshift. So you learn something new every day. I always wondered, though, like, how do they do that? And the more we keep looking, the more we'll figure out a lot more ways or tools and different things they're utilizing to their advantage to calculate things like distance and how fast something moves and stuff like that. That's pretty dope.
About 700 million light-years away from the Earth was a blank void. They estimated that this void was around 330 million light-years wide. This void is so big that our galaxy could fit in that space several billion times. Inside this void, though, barely any galaxy or celestial body existed. Over time, the universe has been remapped as other scientists have built more detailed maps of our universe over time. We now understand that our universe is shaped more or less like a giant web. Most known galaxies in our universe are arranged in extended structures. This arrangement of galaxies is known as filaments. Some of these filaments wind through the cosmos and meet in some areas. These areas of intersection give birth to regions with a high concentration of galaxies called clusters. If these semi-straight filaments wind and intersect in certain areas, there would be empty voids between them with little to no activity. These voids are not insignificant in size. They make up about 80% of our observable universe. Many of these voids span between 30 to 300 light-years across. There is one such void of extreme interest to scientists. This void is known as the Bootes void. It is called so because it appears to lie in the Bootes constellation. Scientists believe that this constellation looks like a herder driving a plow. This Bootes void is one of the immense voids in existence. This size is why researchers have given it the title supervoid. Some scientists believe that the Bootes supervoid is the product of merging some smaller voids. They think that in the early days of the universe, all of its matter was much more compact than it is now, and that it may have been evenly distributed within the small space it occupied. They likened it to a bowl of soup. However, this uniformity was disturbed by random quantum fluctuations. These fluctuations soon created slight differences in the distribution of cosmic matter and elements. Some eras became a little denser than others. These denser areas developed more gravitational pull due to the presence of more bodies and parts. This increased gravitational pull allowed them to pull even more bodies into their orbits, taking even more matter away from areas with less density. These even dense areas still—
Yeah, but how does that not upset the balance of things when it does stuff like that? Just a question out of curiosity. You know what I'm saying? Like, that wouldn't that upset the balance when you pull things from other areas, though? Like, that's what about space that I guess still is an enigma to me and has me so fascinated, is because of we still don't understand how certain things happen, whether it be a supernova and it starts releasing gases and it affects this. How does things restore its balance, or whatever that balance is, you know?
More matter away from areas with less density. These even dense areas still drag more matter into their orbit, and the cycle continues infinitely. At the same time, the universe expanded greatly and constantly. These fluctuations, which started at a quantum level, grew until they spanned millions of light years in size. Smaller matter clusters began regrouping into what we now know to be galaxies. These immense structures, and even the smaller ones, have provided astronomers with a kind of window into the past of the universe. They have gained insight into what the universe must have looked like in that early era. Advancements in technology, enhancements, and modifications of telescopes have made it easy for scientists to draw up more detailed versions of the map created by Robert Kirshner and his crew. Popular opinion among scientists is that our Milky Way and its parent galaxy are inside one of these cosmic voids. As we mentioned earlier, it is not that there cannot be activity or the presence of matter in these voids. There can be, but activity is pretty sparse. Some researchers made an observation in 2013, and a more recent study seconds their findings. These findings show that we live in one of these sparsely populated cosmic voids. The void we are said to dwell in was dubbed the Keenan, Barger, and Cowie void, or the KBC void for short. The void was named after the astronomers that discovered it. Spanning about 1 billion light-years across, the KBC void is about 7 times larger than the average void. It is spherical and is said to be surrounded by a shell of galaxies, stars, and other cosmic bodies. However, our KBC is not the largest void. The largest void is called the cold spot. This cold spot is an unusually cool region in the background radiation that has lingered throughout the universe since the Big Bang occurred. The radiation is known as the cosmic microwave background. While this CMB is full of barely noticeable temperature variations, the cold spot has undoubtedly remained a mystery to researchers.
I hate that they make the reference of radiation to a microwave, you know what I mean? And then you go later on. I want you to think about that later on when you get hungry and you're ready to heat something up real quick and you go to throw it in the microwave and stuff like that. You know, I had a cousin that traumatized me as a kid and was just like, and this is, I got off topic, but my bad. But anyway, told me if I stood in front of the microwave, I would never have kids, stuff like that. You know what I mean? So just to hear them make that reference just did something to me right then. But my bad, continuing on.
The cold spot has undoubtedly remained a mystery to researchers. The cold spot's most fascinating feature is that it constantly remains colder than its surroundings.
Yeah.
The reason for this remains quite unknown. This temperature deviation between the cold spot and its surroundings has led scientists to propose that it could result from a massive supervoid spanning about 1.8 billion light-years. It is also estimated that about 10,000 galaxies are missing from this supervoid. If this is true, it would mean that the supervoid that causes the cold spot's cooler temperature is the largest void in the universe, composing about 20% less matter than anywhere else. However, the theory about the cold spot getting its temperature drop from a supervoid has been ruled out. A study by astronomers at Durham University, UK, has shown that it is likely not the case. Using the Anglo-Australian telescope, these astronomers surveyed the redshifts of 7,000 galaxies, charting light sources moving away from Earth, all while the universe kept expanding. From the data provided after the conduction of the research, they explained that there was no supervoid capable of explaining the cold spot's temperature variation from its surroundings. Well, at least not within the standard cosmological theory. They ruled out the possibility of one supervoid causing the extra chill in the cold spot. However, they believed that a bunch of smaller voids, surrounded by a cluster of galaxies, made up the cold spot. This idea was likened to a foam of soap bubbles. They said that the overall density of matter in the smaller voids is the same as if found elsewhere in the universe outside the cold spot. The scientists who conducted this study at Durham University estimate there is a 1 in 50 chance that the cold spot may have arisen due to random variations under standard cosmology. Outside standard cosmology, a more exotic reason for the emergence of the cold spot would have to be found. One such exotic theory would have to be the one that says that a collision between our universe and a bubble universe caused the cold spot. This collision would be consistent with the multiverse theory. Scientists believe that our universe is but one of the many millions of galaxies out there. They also believe that sometimes these universes collide and interact. Maybe, just maybe, a much smaller parallel universe interacted with our universe just mere hours before they were separated by cosmic inflation. These may or may not have left an imprint on the CMB. However, we cannot run.
So, and that leads me to a question I had the other night, right? And I'm sitting there and I'm thinking, I'm like, okay, if that's the case and something could have happened to where we were, are we still parallel? Are we still a parallel universe? How do we even know? And if we are not parallel and something happened and the Big Bang and we're actually away, what does that mean for us? You know what I'm saying? How does that play into effect of the whole parallel universe theory? Or are we still parallel? Like, I have so many, you don't even want to know how deep it gets, bro. And I know y'all be looking at me like I'm crazy, but I have questions that have questions that have questions. You get what I'm saying?
With this claim or theory, because such claims must be backed up by irrefutable evidence.
Right.
This evidence has to be consistent with other cosmological observations. Tom Shanks of the Durham University Center of Extragalactic Astronomy suggested that such a collision between two universes should have produced an identifiable polarization signal in the cold spot. In addition to this suggestion, the Planck team included a more detailed examination of the polarization of the CMB or cold spot radiation, which is almost wholly independent of its temperature profile. Planck's multi-frequency data was used to understand better the nature of cosmic anomalies like the cold spot. The idea is to eliminate foreground sources of microwave emissions in our galaxy, such as gas and dust. However, despite careful examination, the Planck team found no evidence of anomalies in the polarization. According to the Planck team's latest findings, maps do not confirm or deny the nature of anomalies such as the cold spot. It leaves many possibilities that would further improve our understanding of the cosmological parameters. Any new knowledge gained would allow us to provide better explanations for unusual phenomena such as the cold spot. We would require new data from sensitive telescopes such as the Meerkat Array. Recent and upcoming facilities such as the Giant Magellan Telescope and the Square Kilometer Array also have a role to play. However, the idea of a multiverse exists only theoretically, at least for now. Pop culture, however, has no qualms with running with the idea of the possibility of a multiverse. Almost every Marvel movie has an element of that in them. It is a fascinating theory, not to mention a fascinating idea. Scientists are also looking for anything supporting the claim of the multiverse as a reality. Another theory about how the cold spot was formed is that the cold spot, also occurred due to the primordial density fluctuations that caused the universe to expand and develop the cosmic webs we see today. The fact that the possibility of a supervoid being the cause of the cold spot has been ruled out, however, brings credence to the possibility of a multiverse being real, as that is one of the explanations for the cause of the cold spot, however weird the idea may be. If the theory of the multiverse is proven to be accurate, then millions or billions of universes may exist just like ours.
So, with that being said, do y'all still think we're alone? If that's possible, there's no possible way we could be the only ones. We're not that lucky. You know what I'm saying? We're just not that. No way.
We do not fully understand, though, how the cold spot came to be. But one thing is sure. The continuous study of the cold spot would give birth to many more amazing discoveries. The supervoids are lonely places. The Booty's supervoid, for instance, with its size, should easily accommodate about 10,000 galaxies. However, a scant 60 is what is present in that supervoid. The galaxies in this supervoid are so scattered and sparsely distributed that if the Milky Way were located in the Boots void, we would not have known other galaxies existed till the late 1960s. The distance between the Milky Way and the next available neighboring galaxy would be vast. We must also understand the nature of dark energy or dark matter, how it works, and how it affects our universe's evolution. As scientists get closer to unraveling the mysteries of the cold spot phenomenon, they use data obtained from the Dark Energy Survey to confirm the existence of the Eridanus supervoid. The Eridanus supervoid is one of the largest supervoids known to humanity. In a paper published recently, this previously hypothesized but now confirmed void in the cosmic web could be a possible cause of the cold spot anomaly. The cosmic web is made of clusters of galaxies and more prominent clusters of galaxies called superclusters. These clusters and superclusters are drawn together by the attractive force of gravity and accelerated apart by the repulsive force of dark energy. Voids then appear between the clusters. The cosmic web resembles a block of Swiss cheese, with all the holes representing the voids. These voids are vast regions of space with fewer galaxies, so less ordinary matter and dark matter exist between the galaxy clusters. The Eridanus supervoid, one of the most extensive voids, is a massive, elongated, cigar-shaped void in the cosmic web. The Eridanus is about 1.8 billion light-years wide and is said to contain 30% less matter than the surrounding galactic region.
So hearing this, it's starting to make me think, man, there could be a possibility that these black holes could be little portals to another universe. You get what I'm saying? Like, and I know that's so far-fetched, but how do we rule it out completely? We don't know. Nothing that went into it has come back out to give us any information about what it just did, or why wasn't it destroyed, or where did it go, or where did it end up at? You know? So it's like, I don't know why it makes me think that, but it does kind of.
The center of this supervoid is said to be 2 billion light-years away from Earth. Using dark energy survey data, scientists created a map of dark matter in the same direction as the CMB cold spot by observing the effective gravitational lensing. It is a phenomenon that occurs when the gravitational influence of dark matter warps the path of light. This dark matter map, created by the data obtained from the Dark Energy Survey, is the largest ever made. Dark matter is mapped over a quarter of the southern hemisphere. Previously, scientists counted the number of galaxies visible in the region of the CMB cold spot. An underdensity of galaxies was discovered in that region. Also, according to the new map, there is a matching underdensity of invisible dark matter. The Dark Energy Survey is a global effort to understand better the role of dark energy in the universe's acceleration. The dark energy server uses a 570 megapixel digital camera. This camera is called the D camera. The D camera is used to document the hundreds of millions of galaxies, supernovas, as well as patterns of the cosmic web. The Fermi National Accelerator Laboratory of the U.S. Department of Energy oversaw the design and integration of the camera's components. About a decade and a half ago, scientists believed that voids would affect the current acceleration rate of the universe. Gravitational forces compete with the expansion of the universe caused by dark energy. This competition results in the deepening of some voids between galactic cluster photons or light particles entering a void before it begins to deepen.
Is that a good thing or a bad thing?
These light particles also leave the voids after they have deepened. Although
Is that a good thing or a bad thing? They said it can affect the expansion of the universe. Is that a good thing or bad thing? I heard before, back early on, starting to learn about this stuff, that they were worried about the rapid expansion of the universe. You know what I mean? So what does that even mean? You know, but in this one, they didn't make it sound like a bad thing, like it was alarming.
Findings confirm that the Eridanus supervoid is massive. There is no explanation given to the discrepancy between the predictions of the current standard cosmological model used to predict the behavior of dark energy. The lambda cold dark matter model is the model used to predict the behavior of dark energy. The observed change in temperature in the cold spot can be attributed to the supervoid's effect on photons from the CMB. The coincidence of these two individually rare structures in the cosmic web and the CMB cold spot is insufficient to prove causality with a scientific standard. It is sufficiently novel in the reasonably lengthy history of the issue of the CMB cold spot problem that after this, people will be certain there is a supervoid. This may be a good thing because some people have debated in favor of other ideas. Scientists believe that there are two ways of looking at this problem. One way to look at it is that either the lambda CDM model is correct, or the CMB cold spot is merely an anomaly that just happened to be in front of a massive supervoid. The other way of looking at it is that the lambda CMB model is incorrect, and the integrated sex wolf effect is more potent in supervoids than...
Yeah. I got a lot more questions now. I can't help it. I got a lot more questions now. But I don't know, man. It makes me nervous. You know what I'm saying? When stuff starts appearing or disappearing in a sense, you know? And like I asked in the beginning, is there a balance? What is a balance for space, for the universe? What is balance? Do we even know what balance is? Because we haven't even figured out what the dark matter is, how much of it, you know what I'm saying? So how do we even know what's balanced? We know with our planet, if the ozone layer starts to deteriorate and it gets to a certain point, we're in trouble. So we need to keep it balanced. Like with the universe, like what do we even know to be able to say, oh, we're getting off balance, we're tipping the scales? That unknown to me that's nerve-wracking. You know what I'm saying? So, but y'all get at me in the comment section, man, and let me know what you thought about this video. Super informative though. It's your boy L. Stick around and stay tuned, man. Till next one, I'm gone. Peace.